My name is Flash Isaac, and I'm a teacher from the future. Stoichiometry. Stoichiometry is the nightmare of 98% of chemistry students. In fact, if someone says chemistry is difficult, there is high chance that it is because of stoichiometry. The good news is that the flash is always here for you. Your own is to pay attention, watch, get the app, follow the questions, do your assignment, and you become so big in chemistry. Yes. Stoichiometry tries to tell us or try to compare what is and what should be. This will make sense to you later when I am analyzing stoichiometry combination. Remember, I told you that the unit of matter is atoms. And this thing has billions and billions and billions of atoms. They don't exist independently because of their reactivity. They are unstable. They combine to form molecules, which means mass atoms exist as molecules. Elements combine to form compound. So all these are chemical combination, and they are under chemical changes because new substances are formed. If no new substance is formed, then that is a physical change. Melting of ice block. Water has changed from ice, solid to liquid, but the identity remains. But burning, when you burn, a new substance is formed. Carbon dioxide is released and other gases, and they form ashes. The laws of chemical combination you should know are the law of definite proportion, multiple proportion, and conservation of matter. When we say something is conserved, it means that it remains. It is not created nor destroyed, although it can change from one form to another, which means I've already given you the law of conservation of matter. Get Lussac's law, Avogadro's law, chemical symbols, formulas, and equations, relative atomic mass, isotopy. Masses of all elements are not whole numbers because of isotopy. When you see an atom with the same atomic number, they have different atomic mass. Chlorine, you have chlorine 37, chlorine 35, the same chlorine, different masses. That is isotopy. So how do we then calculate to arrive at the relative atomic mass of chlorine to be 35.5? Mole concept. What is mole? Mole is a fundamental quantity, and it is an amount of substance that contains as many elementary entities as there are 12 grams of carbon-12, or any number that contains the Avogadro's number is the mole. What is Avogadro's number? You see, all these are connected. In fact, you can't really talk about one without indirectly thinking of the second one. 5 centimeter cube of carbon-2 oxide was exploded, boom, with 150 cm cube of air containing 20% oxygen by volume. Which of the reactants was in excess? As little as this question is, it requires a lot. 50 cm cube of carbon-2 oxide. They did not say carbon-3 oxide. They did not say carbon-4 oxide. They said carbon-2 oxide. And what is cm cube? Cm cube speaks of volume, which means volume of carbon-2 oxide. Volume is equals 50 cm cube. And volume of what? Of CO. Carbon-2 oxide is CO, also referred to as carbon monoxide. This was exploded with 150 cm cube of air, which means volume of air is equals 150 cm cube. And it says that this air contains 20% oxygen by volume. This air contains 20% oxygen by volume. So volume of oxygen is equals 20% of 150 cm cube, because the volume of air was 120 cm cube, 150 cm cube, and the volume of oxygen is 20% out of the 150 cm cube. Can we solve that? Percentage means over 100. So 20 over 100 times 150. This is 10 cancels 10. 10 cancels this. This will give you 30 cm cube, which implies that the oxygen in the air is 30 cm cube, and the remaining air or remaining volume is equals 150 cm cube minus 30 cm cube. This is equals 120 cm cube. So oxygen removed from the air, the remaining volume is 120 cm cube. Now, if carbon monoxide is exploded or is burning, when there is burning or explosion, we speak of oxygen, because oxygen is the part of air that supports burning. Oxygen is the component of air that supports burning. Air is a mixture containing nitrogen about 78%, oxygen about 21%, that is approximately 21%. You have carbon dioxide about 0.03%, argon and other impurities. These are the constituents of air. But oxygen is what supports burning. If you remove oxygen from air, then you cannot burn. You can't burn without oxygen. So carbon dioxide being exploded, it simply means reacting with oxygen, because it is that oxygen that we need for the explosion. What does that tell you? It simply means that carbon dioxide and oxygen, O2 molecule, are what we need for the reaction. Oxygen usually exists as a molecule. The atom exists as a molecule, O2. Now, I told you that stoichiometry explains what is and what should be. What is and what should be. If carbon monoxide reacts with oxygen, because I told you when you hear burning or explosion, they are just trying to tell you that react with oxygen. That's what they are telling you indirectly. If carbon monoxide explodes with oxygen, what is supposed to happen is that carbon monoxide plus O2 will give you CO2. Here we have one carbon. Here we have one carbon. Carbon is balanced. Here is 1. So 1 times 2, 2 plus 1, 3. We have 3 oxygen here. Here we have 1. 1 times 2, we have 2 oxygen here. Oxygen is not balanced. To carry out stoichiometry, equation must be balanced. How do you know that an equation is balanced? The number of atoms here should be the same as the number of atoms on the other side. In that case, the equation is balanced. Since what is not balanced is oxygen. So how do we balance oxygen? Let's increase here. If we increase here, we have 2 carbon. If 2 carbon is here, here must automatically be 2 carbon. To make this carbon 2, it is like this. So here carbon is 2, carbon is 2. Here oxygen is 2, 4. Oxygen is 2 times 2, 4. Which means they are both balanced. 2 carbon, 2 carbon. 4 oxygen, 4 oxygen. Now, add this to your dictionary. When CO and O2 react, this is the balance equation. 2 carbon, oxygen, and this. So if you see question like this again, you know that this is balanced. And after solving many questions, the ones that are said, you know how you see the balance equation form. And in many cases, for complex ones, they will give you the balance equation. They know that you have issues balancing the equation. Therefore, don't worry about how do I balance complex equations. Know all these simple ones. Complex ones, they will give you. Even in some questions, they will balance the simple equation for you. What's next? Let's deal with what should be. What should be. While dealing with what should be, you should know two things: mole and molar mass. So what should be is that 2 moles of carbon monoxide must react with 1 mole of oxygen to give you 2 moles of carbon 4 oxide. When you burn, carbon 4 oxide is released. So any burning that takes place, at the product side, there should be CO2. And at the reactant side, there should be oxygen. 2 mole of carbon, the number here is the number of mole. Here is 1. 2 moles of carbon monoxide is required to react with 1 mole of oxygen to give us 2 moles of carbon 4 oxide. Now let's see what happened. The volume of carbon monoxide is 50 cm cube. If, according to the reaction or according to the balance equation, 2 moles of carbon monoxide is required to explode with 1 mole of oxygen to give us 2 moles of carbon 4 oxide, it means using here should be 25 cm cube. And here is also 2 moles. Here should be 50 cm cube. In terms of volume, since CO is 50, oxygen is supposed to be 25 cm cube, CO2 is supposed to be 50 cm cube. 50 cm cube of carbon 4 oxide was exploded with 150 cm cube of air containing 20% oxygen. And 20% oxygen in air is 30 cm cube, which means they exploded 50 cm cube of carbon monoxide with 30 cm cube of oxygen. What does it mean? What we actually needed was 25 cm cube of oxygen, because this is half of this. We are given 30 cm cube of oxygen. It simply means that oxygen is in excess. It's in excess. If you are giving us 50 cm cube of carbon monoxide, if you are giving us 30 cm cube of oxygen, what should be here? It should be 60 cm cube of carbon monoxide. But you gave us 50 and you are giving us 25, which means oxygen is in excess by 5 cm cube. The one that is in excess is the excess reagent. The one that is not enough is the limited reagent. So which of the reactants was in excess? Oxygen was the excess. If you ask which of them is the limiting reagent, the limiting reagent is simply the one that is not enough. That is carbon monoxide. There is another way this is usually asked that confuses students. They will tell you, what is the volume of the residual gas? If they ask you the volume of residual gas, or what is remaining in the container, what is remaining in the container is the remaining air, volume of air, which did not react. That is 120 cm cube. Then all the oxygen, all the carbon 2 oxide reacted, nothing remaining. Then out of the 30 cm cube of oxygen, only 25 cm cube reacted, meaning 5 cm cube did not react. 5 cm cube. Welcome to chemical combination and stoichiometry. The next episode, oxygen was in excess. We needed 25 cm cube of oxygen to react with 50 cm cube of carbon monoxide, but we are given 30 cm cube of oxygen, which means oxygen was in excess by 5 cm cube. According to the balanced equation, we needed 2 moles of carbon monoxide to react or to explode with 1 mole of oxygen. And 2 moles of carbon monoxide was 50 cm cube. If 2 moles equals 50 cm cube, therefore 1 mole is supposed to be 25 cm cube. Therefore, oxygen was excess. And the limiting reagent was carbon monoxide. Limiting reagent is the one that is not enough. And for chemical reactions, it is the limiting reagent that determines the volume produced. Because stoichiometry is a branch of chemistry that helps us to calculate amount of substance or quantity of substances. If you bake cake, you have flour and you have eggs. Now, if you need 50 eggs to bake one cake, and you need let's say 2 kg of flour to bake one cake. I'm just giving you instance. Bakers, don't be mad at me. So you need 50 eggs to bake one cake, then you need 2 kg of flour. Now, a situation where you have 100 eggs and 8 kg of flour. Normally, if 2 kg of flour can bake one cake, 8 kg should be able to bake 4, right? But you have just 100 eggs. 100 eggs can bake 2 cakes. Flour is in excess. Eggs is limiting. So it is the limiting reagent, the egg that is not enough, that determines how many cakes you can bake. Since we have just 100 eggs, you use that 100 eggs to bake 2 cakes. Then you use 4 kg out of the 8 kg of flour available. Then you have extra 4 kg of flour which is not used. So it is the one that is not enough that determines the output. Then I also went ahead to look for the volume of the resulting gas or the volume of the residual gas, in case you are asked. The volume of the resulting gas in that question is the remaining oxygen, which is 5 cm cube. That was the excess oxygen. Then the volume of carbon dioxide produced, that was 50 cm cube, plus the volume of air which did not react, that's 120 cm cube. So 120 cm cube plus 50 cm cube plus 5 cm cube is the volume of the resulting gas. Anytime in stoichiometry you are asked to calculate volume of resulting gas, it is simply the volume of the product formed, the excess gas, you add it. Then if they told you that air, oxygen was from the air, then you add the volume of air that did not react. But if no air was mentioned, therefore your resulting gas or the volume of the result or the residual gas is the volume of the product plus the volume of the gas that is in excess. We will see more from that. Laws of chemical combination. For there to be chemical combination or a chemical combination, there are certain laws we have to follow. The first one here is the law of definite proportions. First stated by Joseph Louis Proust in 1797. The second law is law of multiple proportions, stated by John Dalton in 1803. That is atomic theory. We will soon get to atomic theory. Law of conservation of matter by Antoine Lavoisier in 1789. Then there is law of reciprocal proportion, which is similar to the law of multiple proportion. We won't do much on that. Let's see. What did the law of definite proportion state? It says that all pure samples of a chemical substance contain the same elements combined in the same proportion by mass. All pure samples of chemical substance contain the same elements combined in the same proportion by mass. What does it mean? If you bring out H2O, water has 2 hydrogen and 1 oxygen. In Nigeria, this is water. In America, this is still water. So anywhere you go, water contains H2 and O in the same proportion by mass. If you analyze water in America, you will see that the mass of hydrogen in water is 2. The mass of oxygen in water is 16 grams. 2 grams, 16 grams. The total mass of water is 18 grams, which means the percentage of hydrogen in water is 2 grams, percentage by mass is 2 grams over the total percent, 18 times 100. This is 11.1%. So I've taught you how to calculate percentage by mass. If you are given a compound and you have to look for the percentage by mass, look for the mass of that particular. If you are looking for percentage by mass of element in the compound, look for the mass of that element in the compound, divide by the total mass of the compound and multiply by 100. So the percentage of hydrogen in water is 11.1%. Now how about oxygen? Oxygen will simply be 100% minus 11.1%, or the mass of oxygen 16 grams over the total mass of water 18 times 100. This should give you 88.9%. So anywhere you go in this world, the percentage by mass of hydrogen in water is 11.1%, of oxygen is 88%. So long the substance is pure, anywhere you go, the substance will contain the same elements combined in the same proportion by mass. That is the law of definite proportion. The law of multiple proportion states that if two elements can combine to form more than one chemical compound, then the various mass of one element that combine separately with a fixed mass of the other element are in simple multiple proportions. This means that, look at sulfur and oxygen. Sulfur can react with oxygen to form SO2. The same sulfur can react with oxygen again to form SO3. This is sulfur 4 oxide, this is sulfur 6 oxide. In both cases, the mass of sulfur here is 32 grams. The mass of sulfur here is 32 grams. The mass of oxygen here is 32 times 16, is 16 times 2, O2, that is 32. The mass of oxygen here is 16 times 3, that is 48 grams. So the mass of oxygen here and here, the ratio is 32 grams ratio 48. 32 ratio 48. And once you break it down, you get 2 ratio 3. You see? So if two elements can combine to form more than one chemical compound, sulfur and oxygen can combine to form more than one compound. The first compound, SO2, another one, SO3. The various masses of one element that combine separately with a fixed mass of the other. So the mass of one element that combine with a fixed mass of the other are in simple multiple ratio. So O, they are in simple ratio. The mass of oxygen here is 32. The mass of oxygen here is 48. And the ratio is 2 ratio 3. And take note, they are whole numbers. While the mass of sulfur is fixed, 1 ratio 1. So that explains that law. And Gay-Lussac's law. Gay-Lussac's law is the basis for stoichiometry. Anywhere you are asked, which law is the basic for stoichiometry? It is Gay-Lussac's law, or Gay-Lussac's law of combining volume. The law states that when gases combine, they do so in volumes which are in simple ratio to each other. So when gases combine, the volume at which they combine are in simple ratio to each other and to the volume of the product. Relative atomic mass. The masses of all elements not equals whole number because of relative atomic, because of isotopy. Now, isotope, you have chlorine, atomic number 17, mass 35. You have another chlorine, atomic number 17, mass 37. So the same atomic number, different atomic masses. And the reason for isotopy is simply neutron. They have the same number of proton but different number of neutron. To get the number of neutron here, the mass minus the atomic number should give you the number of neutron. And for a neutral atom, the number of electron is equal to the number of proton. How do you now look for the atomic mass of chlorine? Because if I ask you for atomic mass of chlorine, you can't be telling me 35 or 37. We'll be getting confused. Or I will have to be giving you mass to use. At the end, we're able to solve the relative atomic mass of chlorine to be 35.5. So in isotopy, how do you find relative atomic mass? Each of the isotope, they have their abundance, percentage abundance. So to find relative atomic mass of any isotope, it is simply the percentage by mass of isotope A times the mass of isotope A plus percentage by mass of isotope B times mass of isotope B. Abundance of chlorine 35 is around 75%. For this guy, it is around, that is 25%, because percentage should be 100 maximum. If you use this and substitute here, 75 over 100 times 35 plus 25 over 100 times 37, you get the relative atomic mass of chlorine to be 35.5. So that is it for isotopy. And something else you should know is Avogadro's law. Avogadro's law states that equal volumes of gases at the same temperature and pressure contain the same number of molecules. Equal volume of gases at the same temperature and pressure, they contain the same number of molecules. Which means if I have 200 cm cube of chlorine gas, 200 cm cube, and I have 200 cm cube of oxygen gas, so long they are at the same temperature and pressure, they will contain the same number of molecules. So the number of molecules here will be the same thing as the number of molecules here. You need not calculate. And mole is a substance that contains as many elementary entities as we have 12 grams of carbon-12. It's a number, or is an entity that contains Avogadro's number. Mole can be as mass or as volume or as number. Mole as a mass, it simply means that 1 mole of Cl2 is simply the mass of Cl2. The atomic mass of Cl2. Mole as a volume is 1 mole of a substance should contain 22.4 dm cube. And mole as a number says that 1 mole of an atom should contain Avogadro's number, which is 6.02 times 10 to the power of 23. Ladies and gentlemen, we've gone very, very deep. Now let's round it off with these formulas and a question under isotopy. Number of moles is mass over molar mass. Density is mass over volume. Number of mole is concentration times volume. While in cm cube, number of mole is Cv over 1000. Mole is volume over 22.4 dm cube. That is at standard temperature and pressure. And number of moles is equals number of molecules over Avogadro's number. We will see that under calculations. The applications will surface very, very soon. If the relative molecular mass of an element is not a whole number, it can be deduced that the element is dash. A. Naturally radioactive. B. Abundant in nature. C. A transition metal. And D. An isotopic mixture. It is an isotopic mixture, and it is the reason isotopy is the reason why relative mass of an element is not a whole number. So this question says, calculate the relative molecular mass of calcium hydrogen tetraoxosulphate 6. This question would have been very, very simple if only you know the formula for calcium hydrogen tetraoxosulphate 6. Calcium hydrogen tetraoxosulphate 6 is simply CaHSO4 2. That is calcium hydrogen tetraoxosulphate 6, CaHSO4 then 2. We are asked to look for the mass. We are given the mass of calcium, the mass of hydrogen, the mass of sulfur, and the mass of oxygen. It is simply for us to substitute. What do you do in this case? The mass of calcium is 40. Bracket plus, you open up the bracket. The mass of hydrogen is 1 plus the mass of sulfur is 32. 32 plus the mass of oxygen is 16. But how many oxygen do we have? 4. We therefore say that 4 times 16. So oxygen is 4 times 16. Bracket closed. 2. Just the way this 4 below oxygen says 4 times oxygen, that is how this 2 below everything here says 2 times everything in the bracket. Which implies that anything you arrive at inside here, multiply by 2. That will be what is here. So this will simply give you 40 plus 1 plus 32 plus 64, if I am right, times 2. If I am also right, this is 40 plus 97 times 2. And 40 times 97, 40 plus 97 times 2 is 40 plus 194. That is equals 234, as seen in option D. So option D is the correct option. The relative atomic mass of naturally occurring lithium, consisting of 90% lithium-7 and 10% lithium-6, is dash. This is under isotopy and relative atomic mass. Relative atomic mass. We have lithium, one with atomic mass of 7. We have lithium, one with atomic mass of 6. They both have the same atomic number. Lithium, let's call this lithium A. Let's call this lithium B. Li, Li. The percentage of lithium A is 90%. Percentage of lithium B is 10%. Therefore, the relative atomic mass of lithium will be percentage of lithium A, 90%, 90 over 100, times the mass of lithium A, 7, the one at the top is the mass, 7, plus percentage of lithium B, 10%, 10 over 100, times the mass of lithium B, the mass of lithium 6, times 6. So this will give you the relative abundance of that lithium, which will give you 6.9. Therefore, the relative atomic mass of lithium is 6.9. Now, relative abundance of the isotope. Chlorine consists of 2 isotopes of mass number 35 and 37 in the ratio 3:1. 3:1. The total ratio is 3 plus 1, 4. When you are given ratio question, first of all, find the total ratio. The total ratio is 4. And if the first, let's call this A and let's call this B. A will simply be 3 over 4 and B will simply be 1 over 4 of the total ratio. What is the abundance of the one with 37? If this is 3:4 and this is 1:4, 3:4 is simply 3 over 4 times 100. This is the abundance. The second one will be 1 over 4 times 100. 1 over 4 times 100, that will give you 2 here 2, 2 here 50, 2 here 1, 2 here 25. So this is 25%. So the percentage abundance of this guy is 25%, while the percentage abundance of the other guy is 75%. Please take note of this. Anytime it comes to isotopic question for chlorine, you need not solve. Chlorine 35, the abundance is 75%. Chlorine 37, the abundance is 25%. It is fixed. And if you are asked to look for the relative atomic mass of chlorine, it is 35.5, unless they decide to manipulate the figures. But this is the standard. And I've also told you how to solve. What about a situation where you are not given the percentage abundance? What do? if you are not given percentage abundance, let's say for chlorine, you will simply say, and you are given the relative atomic mass 35.5. This is equals percentage of the first one. Since it is not given, it is S over 100 times, let's say you are given mass of the first one 35, plus percentage of the second one we are not given, but we know that the maximum percentage we can have is 100%. If this one is already carrying 8%, it simply means that the percentage of this other guy will be 100 minus S%, which means if here is 25%, here will be 75%. If here is 75%, here will be 25%. If here is 60%, then here will be 40%. So 100 minus S over 100 times 37. If this is not chlorine, this is any other element. Here, if they gave you the relative, then mass of the first isotope here, mass of the second isotope here, then S be the percentage abundance of the first, 100 minus S percentage abundance of the second. So with this formula, you'll be able to calculate percentage abundance of any isotope if you are not given. I think I've said that enough. And the next question here says, an element S with relative atomic mass of 16.2 contains two isotopes. The first one has mass of 16 and the relative abundance is 90%. The second one has a mass of M and the relative abundance is 10%. Find the value of M. This is a very interesting question. You put percentage abundance is 16, relative atomic mass rather 16.2. This is equals percentage abundance of the first one is 90 over 100 times the mass is 16 plus percentage abundance of the second one is 10 over 100 times the mass is not given times M. Ladies and gentlemen, if from here you cannot say 90 over 100 times 16 plus 10 over 100 times M, which is M over 10, then you collect like terms and get 18, I will be so disappointed at you. So 18 is the correct answer to that question. And let's see this question. An isotope has an atomic number of 15 and a mass of 31. The number of protons it contains is dash. The number of protons is simply atomic number. So anytime you say atomic number, that is the number of protons. So it is 15. No need to solve. An element Z contains 80% of zinc with mass of 16 and 20% of zinc with mass of 18. Its relative atomic mass is dash. Relative atomic mass will simply be 80 over 100 times 16 plus 20 over 100 times 18, and that will give you 16.4. Combination. Volume of oxygen 150 cm cube. Volume of hydrogen 150 cm cube. Hydrogen and oxygen H2 plus O2. And we know that if hydrogen and oxygen are sparked, we are definitely getting water. So H2O. And the temperature actually shows that at 100 degrees Celsius, water should be gas. So we are dealing with gases. Water gas, not water liquid or water solid. It makes sense now. In water, from here we have two hydrogen, which is balanced because we have two hydrogen here. Here we have oxygen. Meanwhile, here we have only one oxygen. We therefore need to increase oxygen so that oxygen will be 2. How do we increase oxygen? Don't touch here in balancing of equation. No. Touch here. 2. If here is 2, oxygen is balanced, but hydrogen has been increased by 2. To account for that, we put 2 here. So this is the equation for hydrogen reacting with oxygen. 4 hydrogen, 4 hydrogen, 2 times 2. 2 oxygen, 2 times 2, 2 oxygen. So we balance the equation. You've added another thing to your dictionary. When you balance hydrogen and oxygen, you get 2H2 plus O2 to give you 2H2O. Then carbon monoxide and oxygen, you get, 2CO plus O2 to give you 2CO2. That should be something like that. Now, this means that 2 moles of hydrogen is required to spark with 1 mole of oxygen to give us 2 moles of water. And I told you that stoichiometry compares what should be and what is. What should be is the chemical, what should be is the formula. When you have a balanced equation, the mole ratio tells you what is supposed to happen. The mass also tells you what is supposed to happen. This, for the mass, remember I told you that mole can also be as mass. 2 moles, 2:1:2. The mass of 2H2 is 4. The mass of hydrogen is 1. 1 times 2 is 2 times 2, 4. The mass of 1 mole of oxygen is 16 times 2, that is 32. The mass of 2 moles of water, 1 mole of water is 18 grams. 18 times 2, that should give you 36 if I am correct. So another thing that should be is that we need 4 grams of hydrogen to react with 32 grams of oxygen to give us 36 grams of water. This is what should be. Now, what is what we are given in the question. In the question, we are given volume 150 cm cube of hydrogen. 150 cm cube. Oxygen 50 cm cube. Oxygen 50 cm cube. This is what is. Let's compare what is to what should be. Let's start with here. Hydrogen is 150 cm cube. If hydrogen is reacting with oxygen in the ratio 2:1 and 2 is 150, what will 1 be? If 2 is 150, 1 is supposed to be 150 divided by 2, 75. This is what is supposed to be. Why? If 2 is 150 cm cube, 2 mole of water will also be 150 cm cube. This is supposed to be. But look at the question. They only gave us 50 cm cube of oxygen. What does that mean? The oxygen they gave us is not enough. Since the oxygen they gave us is not enough, we can therefore not use all the hydrogen. Oxygen will determine the product form. It is the limiting reagent. Hydrogen is in excess. So, what should be the right thing? Since we are only given 50 cm cube of oxygen, which means 1 is 50 cm cube, 2 should be 50 times 2, that is 100 cm cube. 2 here should also be 100 cm cube. Therefore, 50 cm cube of H2 will not react. It is gone. This is what we need for the reaction according to the balanced equation. What they are asking us is the volume of the residual gas. First, there are possible questions they can ask you from here. What is the excess reagent? Hydrogen. What is the limiting reagent? Oxygen, the one that is not enough. Now, the volume of the residual gas is the hydrogen remaining that did not react at all, and we got it to be 50 cm cube, plus the product formed 100 cm cube. So 100 cm cube, the product formed, plus the mass or the volume that did not react is the volume of the residual gas, and that is 150 cm cube. How many atoms are there in 1 mole of hydrogen gas? 1 mole of hydrogen gas. Look at it. This is hydrogen atom. Hydrogen gas, or hydrogen generally, it exists as molecule. You see that we say that chlorine is Cl. But in most equations, chlorine is like this, Cl2. Or we say oxygen atom is O, oxygen molecule is O2. One oxygen atom or one oxygen molecule, one O molecule contains two atoms. One chlorine molecule, this is one chlorine molecule, it contains two chlorine atoms. Therefore, hydrogen gas or hydrogen molecule contains two atoms. And one atom contains Avogadro's number. So one atom of hydrogen contains Avogadro's number, which is 6.02 times 10 to the power of 23. Two atoms of hydrogen gas is simply equal to two atoms of hydrogen. This will be 2 times 6.02 times 10 to the power of 23 to give you 12.04 times 10 to the power of 24 or 1.2 times 10 to the power of 23. And the next question says, the mass of 800 cm3 of a gas at standard temperature and pressure is 1 kg. What is the molar mass of the gas? What is the molar mass of the gas? Look at it. V is equals 800 cm3. Now, the volume of any gas at standard temperature and pressure is supposed to be 22.4 dm3. The mass of this gas, mass is equals 1 grams. So what is the molar mass? This is question. Since this gas is at standard temperature and pressure, we can say that the number of mole is equals volume over 22.4 dm3, which means this is in dm3, which means number of moles is equals the volume we are given is 800 cm3. So 800 cm3 over, since we are given volume in dm3 and the volume here is in cm3, we need to convert this standard volume to cm3. How do we do that? We multiply by 1000. So this will give you 22400 cm3. To convert from dm3 to cm3, you multiply by 1000. To multiply from cm3 to dm3, you divide by 1000. In this case, we need the volume to be in cm3, not dm3. We divide by 1000. Here, we need the volume to be in dm3, so we don't divide by 1000. In summary, at standard temperature and pressure, the number of moles is volume over 22.4 dm3. And since the volume we are given is 800 cm3, we convert this dm3 to cm3 to give us 22,400 cm3. Number of mole therefore becomes 0.0357. Why did we look for number of moles? We are asked to look for molar mass. And number of moles is mass over molar mass. We have mass. Now we have number of moles. Molar mass is therefore equals mass over number of moles. That is 1 over 0.0357. So that will give you 28.0 grams per mole. This is the molar mass of the substance or of the gas. Question here is, in the equation above, what are the values of S, Y, and Z? This is solid. This is hydrochloric acid, aqueous. If it were gaseous state, it would have been hydrogen chloride. This is manganese chloride, water in liquid state, and chlorine gas. Looking at this, to balance this equation, looking for the value of S, Y, and Z simply means balance the equation. The best way to answer questions like this is follow the options and see the one that will give you a balanced equation. Respectively means S first, then Y, then Z. Option A says S is 4. S is 4. If S is 4, it simply means in the reactant side, we have 4 hydrogen and 4 chlorine. Let's see the product side. Here, and it says Y is 2 and Z is 1. So if Y is 2 and Z is 1, how many hydrogen would they have in the product side? In the product side, we will have 4 hydrogen. And how many chlorine? 2 here, 1 here. That is 4 chlorine. It is actually correct to look at it. If here is 4, here is 2, and here is 1. Manganese in the reactant side is 1, in the product side 1. Oxygen in the reactant side is 2, in the product side oxygen will also be 2. Oxygen is 2. Hydrogen in the reactant side 4, in the product side hydrogen is 2 times 2, 4. Chlorine in the reactant side will be 4, in the product side chlorine will be, there's already 2 here. If we put 1 here, 1 times 2 is 2, that is 4. It is balanced too. So option A is the correct option. What mass of water is produced when 8 grams of hydrogen gas or hydrogen react with excess oxygen? What mass of water is produced? Hydrogen react with oxygen to form H2O, which means we need 2 moles of hydrogen to react with 1 mole of oxygen to form how many moles of water? 2H2O, to form 2 moles of water. That is a balanced equation. 1 mole of a substance is also equals the mass of that substance. If you are given hydrogen, what should be is that 2 moles of hydrogen gas react with 1 mole of oxygen to give you 2 moles of water. In terms of mass, we will need 4 grams of hydrogen to react with 32 grams of oxygen to form 36 grams of water, which is the masses or the molar mass, grams per mole actually. 4 grams of hydrogen produces 36 grams of water. And remember, we are told that oxygen is in excess. The excess reagent does not determine the product form. What determines the product form is hydrogen, since hydrogen is a limited reagent. And what should be is that we need 4 grams of hydrogen to produce 36 grams of water. Now we are given just 8 grams of hydrogen. So what will 8 grams of hydrogen produce when it comes to water? Call it S. You therefore say that if 4 grams produce 36, 8 grams should produce S. Cross multiplying 4 times S is equals 36 times 8. S is therefore 36 times 8 over 4. This is 36 times 2. And would that give you 72? Yes. So C is the correct option. And the next question says, what volume of oxygen is required to burn completely 45 cm3 of methane at standard temperature and pressure? Balance equations matters. Oxygen, we are burning methane. Methane is CH4. By the time we are done with all the episodes, you will know all the compounds, their reactions, and the results. Your own is to follow. Get the R for personal practice. Comment, ask questions. Plus oxygen, 2O2 to give us CO2 plus 2H2O. What volume of oxygen is required to burn completely 45 cm3 of methane? So we are concerned about oxygen and this, about the reactant. What should be is that we need 1 mole of methane to react with 2 mole of oxygen to form 1 mole of CO2 and 2 moles of water. 1:2:1:2. And it's 1 mole of a substance at standard temperature and pressure will contain 22.4 dm³. So that is the volume of 1 mole of substance. So how do we get the volume of methane that is required? Since this is 1:2, if 1 is 45 cm3, 2 should be 90. So here is 90 cm3. It therefore implies that we need 90 cm3 of oxygen to burn 45 cm3 of methane. 90 cm cube of oxygen to burn completely 45 cm cube of methane. Is there more? I was even taking it as a serious question. That's the answer. Just the way we've been doing stoichiometry since. This is the equation of reaction. So this time around, they are not telling you to balance the equation. They've given you the equation. What should be is that we need 2 moles of sodium to react with 2 moles of hydrogen gas or of hydrogen to give us 2 moles of sodium hydroxide and 1 mole of water. So according to reaction, we have 2:2:2. That is how it should be. Then since we are given the mass of sodium hydroxide, calculate the mass of sodium hydroxide produced by 2.3 grams of sodium. So when you still see mass produced, what you do is you compare the mass that should be to the mass that you are given. And our concern for this question is the mass of sodium hydroxide produced by sodium. So we are concerned with sodium and sodium hydroxide. What should be is that we need the mass of sodium. Molar mass of sodium is 23. 23 times 2, that is 46. We need 46 grams of sodium to react with hydrogen, although 4 grams of hydrogen, but we are not more concerned about hydrogen, to give us the mass of sodium hydroxide is 23 plus oxygen is 16 plus hydrogen is 1. This is 40. We have 2 moles. So 2 moles of sodium hydroxide is 40 times 2, 80 grams. 80 grams. What should be is that we need 46 grams of sodium to produce 80 grams of sodium hydroxide. And now we are given 2.3 grams of sodium. So 2.3 grams of sodium will produce what? S. Cross multiplying 46 times S is equals 2.3 is equals 80 times 2.3. So S will simply be 4 grams. The mass of sodium hydroxide produced by 2.3 grams of sodium is simply 4 grams, as you can see there. How many atoms are present in 6 grams of magnesium? 6 grams of magnesium. You see, this is the normal comparison. Magnesium. The molar mass of magnesium is 24. Sodium, magnesium. So how many atoms are present in 6 grams of magnesium? You compare what should be to what is. Since 1 mole of magnesium is 24 grams, so 1 mole of any substance will contain the Avogadro's number, which is 6.03 times 10 raised to the power of 6.02 times 10 raised to the power of 23 number of molecules. So 1 mole of magnesium contains 6.02 times 10 raised to the power of 23 molecules. Now, mole as mass. 1 mole of magnesium is 24 grams. So 24 grams of magnesium contains 6.02 times 10 to the power of 23 molecules. Therefore, what will 6 grams of magnesium contain? If 24 grams contains this, 6 grams will contain S. So S is equals 6.02 times 10 to the power of 23 times 6 all over 24. And that should give you 1.51 times 10 raised to the power of 23. If I am correct. If I am wrong, do the correct thing. What volume of 0.25 mole per dm cube hydrochloric acid would be required to dissolve 0.48 grams of magnesium completely? We need hydrochloric acid, 2HCl aqueous, to react with magnesium to form MgCl2 plus H2. This is the balanced equation. We are told that what volume of 0.25 mole per dm cube volume of hydrochloric acid will be required to dissolve this magnesium to dissolve this guy completely. Look at something. That 0.25 mole per dm cube you are given is concentration. Concentration. And anytime you are given value, if maybe 0.25 big M, it also represents concentration, big M. In that case, there is chance that you will use this formula. Big chance when you have concentration. Either this formula or this formula. But looking at the options, we are given the answers in cm cube. So if you are solving in cm cube, we will use this formula. Number of moles is equals concentration times volume over 1000. If you are solving in cm cube. If you are solving in dm cube, no need to divide by 1000. From here, the concentration C is equals 0.25 mole per dm cube. And we are given the mass of magnesium. Magnesium is 0.48 grams. What else? That is it. We need what? The volume of HCl. What we need is the volume of HCl. From the balanced equation, we need 2 moles of HCl to react with 1 mole of magnesium to form 1 mole of magnesium chloride and this. So, this is at what should be. What should. The question should tell us what is. What is that we have, they also give us molar mass of magnesium to be 24. We have mass of magnesium and molar mass of magnesium. Since we have mass of magnesium and molar mass of magnesium, we can simply find the number of moles of magnesium, because number of moles is mass over molar mass. So this is simply 0.48 over 24. That is 0.02. So the number of moles of magnesium is 0.02. This number of moles is what we are given. Comparing to what should be, if we need 2 moles of HCl to react with 1 mole of magnesium, it means 0.02 moles of magnesium will react with 0.04 moles of HCl, because if 1 is 0.02, 2 will be 0.02 times 2. So this is what we need. Back to here. Number of moles is CV over 1000, but we are looking for V. Making V subject formula, volume is number of moles times 1000 over concentration. Now the number of moles here, is it for magnesium or for HCl? We are using the number of moles of HCl because it is the volume of HCl we are looking for. So we use the number of moles of HCl, 0.04 times 1000 over concentration, 0.25. Ladies and gentlemen, that is all you need, and that should give you what? What volume will that give you? 160 cm cube. That is the answer to that question. A solution of sodium hydroxide containing 0.6 grams in 250 cm cube of solution has a concentration of that. Concentration is number of mole. Number of mole is concentration times volume. Number of mole is concentration times volume over 1000. Now the volume is in cm cube. It simply means we are making use of this formula. Concentration is number of moles times 1000 over volume. So what is the number of moles? Number of moles is mass times molar mass. And the mass of sodium hydroxide, NaOH, given is 0.6 grams. The molar mass of sodium hydroxide is 40. So the concentration is mass over molar mass, that is 0.6 over 40 times 1000 over volume, 250. So that should give you 0.06. So that is the concentration. So all these things, when you read the question, they get so confusing, so crazy, you feel you can't do anything. But they are very, very simple. So this is why I've dedicated my strength to make sure I do all the questions in stoichiometry and chemical combination. I think I deserve some accolade. Oxygen in air can be removed using alkaline pyrogallo. Is what we use to remove oxygen. option C is the correct option. And this one says, what volume of hydrogen will be produced if 100 cm cube of ammonia is completely decomposed at constant temperature and pressure? The ratio is 2:1:3. So if ammonia is ratio 2 and we are given 100 cm cube, nitrogen is ratio 1. Ratio 1 should be what? 50 cm cube. And if ratio 1 is 50 cm cube, hydrogen is ratio 3. Ratio 3 should be what? 50 times 3. That is 150 cm cube. So it should be 2:1:3 is 100 cm cube ratio 50 cm cube ratio 150 cm cube. So option B is the correct option. You see, you don't need to solve in most of these questions. And look at this one. It's like the first question we solved in stoichiometry. But this is something I want to point out. 20 cm cube of hydrogen gas are sparked with 20 cm cube of oxygen gas in an mole ether, whatever, at 373 Kelvin, 100 degrees Celsius, and 1 atmosphere. The resulting mixture is cooled to 298 Kelvin and passed over calcium chloride. The volume of the residual gas is dash. Now look at something. I told you volume of residual gas is the volume of the product plus the volume of the gas that is in excess. That is the volume of the residual gas. Now hydrogen is sparked with oxygen. When hydrogen is sparked with oxygen, what do you form? You form water. So the volume of the residual gas will be the volume of the water formed, the volume of the gas that is in excess remaining, and if it is air, any other part of the air. But here, it's sparked with 20 cm cube of oxygen gas, hydrogen, but it says that the resulting mixture is cooled. What is formed is water, gas. Now that the gas has been cooled, it will go back to liquid. So it has condensed. In that case, the product is no longer a gas, it has changed to liquid. The volume of the resulting gas will simply be the excess we have in oxygen, that is 10 cm cube. So the excess oxygen remaining is the only resulting gas, because water produced has been cooled to liquid, no longer a gas. Take note of all that. Ask questions if you have, and go through these videos again. Thanks for watching. Your one and only teacher from the future. I hope you found this class interesting. Feel free to check out the playlist for more amazing videos, and don't fail to install the Flash Learners application right now for notes, videos, and questions to meet all your needs. Subscribe to this channel so you don't miss out any of my sweet videos. See you in the next episode. Don't forget to tell everyone around about the Flash Learners. Bye.